Welcome to 8-Bit Basic. Today's program is Musical Chairs by Joey Latimer. It's from Family Computing Magazine, Volume 2, Number 3, from March 1984. We're going to see BASIC running on the TRS-80, the Apple, the TI-99, the VIC-20, the Atari, the IBM PC, the Timex Sinclair 2068, and of course the Commodore 64. This video also contains a guessing competition, so in the later versions of the programs I've used my musical skills and I've rewritten the tune that's played. So please jump into the comments and see if you can name all these wonderful 1980s tunes that get played in musical chairs. I just want to take a second to say a massive thank you. I can't believe the amount of views and subscribers I've gotten just after 2 videos alone. It's just been amazing. Thank you for the comments, your nostalgia, your memories, your suggestions, and the constructive feedback. I really love reading about all the wonderful things that everybody out there knows. It's just fantastic to see how much love there still is out there for these retro machines and classic BASIC. I'm reading every comment. I can't thank you enough for the support. Thanks for being here from the very start of 8-Bit Basic. Take a moment to subscribe if you haven't already. Here is our TRS-80 code. So that the way that our sound is produced, if you look at our data statement 1000 here, and I'll just list it, 1000. We have 204,6, 210,2. So 204 is the note frequency and 6 is the duration. So Musical Chairs is going to play a song. Now I just need to warn everybody, there is going to be flashing screens and flashing colors. So if you're sensitive to that, please be mindful. So here we go with our first version of Musical Chairs. Musical Chairs program. Pressing enter starts the music. The music may stop at any time. Ready? Press enter. Now what a banger. It's time to take away a chair. So that's how it runs on this lovely TRS-80 computer. Over to the Apple, and here's our code. So like the last one that we saw, list 1000, it plays the music from a data table. So 140 is the first pitch and 106 is that note's length or duration. The next note is 124, the length is 32. The next note is 140 and the length is 74. 74 is a crotchet or a quarter note as it's called over in the States. This one does something a bit different with the screen and it's really quite fun. So let's go. Musical Chairs on the Apple. Ready? Press return. That was quite a long round of musical chairs, but I do really like the different blocks that come on the screen. I think that's really cute. Okay, on to the next one. As we look at the TI-99 code, I'm going to explain a couple of things, and it's kind of how all the other ones work as well. So we have a random number generator at 150. That tells the song when to stop playing, so we take away the chair. Line 200 says, is C less than 23? 23 is the number of notes, so that means if we haven't used all the notes yet, keep playing, keep playing. Line 100, that's where our data table starts. So 370 is the pitch, 400 is the duration, 440 is the pitch, and that's an A, and 300 is the duration. So this one is referencing actual frequencies as well. It doesn't have its own specific data to use for notes. It looks like it's using real frequencies. So this is the first one where I've rewritten it to use a banging 80s tune. So let's see if you can guess. Make sure you let me know in the comments. We are ready. Pressing enter. That was mystery tune number 1. Let's look at the next system. the wonderful VIC-20. Just like other machines, up in the first data line here, it's using a data table. So 201 is the first pitch and 93 is the note length. So instead of like its big brother, the Commodore, it uses a high byte and a low byte to create the frequencies. It's just single numbers. So this one, nice and easy to enter. Let's go and enjoy this retro tune. Musical chairs program, pressing return starts the music. The music may stop at any time. Ready, press return. If you were around in the 80s, you surely know that one. Here comes the next mystery tune on the Atari. Another very similar representation of the code. Line 1000, the data 68, that's the first note, 42 is the duration. So it uses its own note table. It's not referencing exact frequencies, but let's jump onto the next tune. We are ready. It took everything I had in me not to sing along with that one. Here's the next one. In the PC version, I've added in this little tempo marker here so I can adjust the speed. So it times the duration by 0.8, just so it lets me slow it all down a little bit. Still uses the same random generator to come up with a random number to stop the musical chairs playing. Again, 75, so we've got lots of notes in this song. The reason there are so many notes, if you have a look, you can see I've got, here's one, a bunch of zeros. So what these zeros do is they act as tiny little rests, because when you play notes like C, for example, if I go C, C, C in a row, the machine will just go C, because it doesn't re-articulate each note. So I've had to put in some little breaks just so you can actually tell that there's a series of notes that's the same pitch in a row. So here is our next 80s tune. Ready. Did you recognize that one? The Timex Sinclair 2068. This took me a little while to type in, as it's only the second time I've ever experienced a keyboard like this. So even though I'm only using the emulator, it still had a few things that I needed to figure out. Let's take the letter K as example. So when I press K, that's our list command. Nice and easy. If I want to create the plus symbol on that, which is the black symbol there, I have to hold Control on the PC keyboard and to create plus. So that's how this emulator works. I'm using 81 emulator, by the way. Now, to access the other ones, I press Control and Shift. Now I'm in a different mode when I press K. That gives me the len, which is the characters on top. So, Control and Shift again, but now I have to hold Shift and press K, and then that gives me the screen string. So once I figured out all of those, I was eventually able to find all of the keys on the keyboard. Let's have a look at the program. I do like we have the nice scroll happening here. This one operates just like the others. You can see at line 1000 there, that's the start of our data line. 9 is the pitch, 0.2 is the duration, 5 is pitch, 0.2 is duration. Sometimes the pitch is minus 60. What I've done there is I've used a very, very low note to simulate a rest. I've needed to do that like the other ones because this machine, when you have notes in a row that are the same pitch, it just sounds like one continuous pitch and it doesn't re-articulate. So that's why those have been put in there. There's our code. Let's run the program. Ready. One of the most iconic 80s riffs. Surely you recognize that one. Our final machine, the Commodore 64. Here it is, all its glorious code. You can see the data table is quite long. There's two reasons. One, because the song is a bit longer, but also 16 is the low byte, 195 is the high byte. Those two get combined to create the note's frequency, and 62 is the duration. So this longer song requires 3 pieces of information to create each note. Remember, the Commodore 64 had quite advanced sound, so the SID chip, you could actually do quite a lot with it. Here is our last 80s tune. Let's do it. We are ready. Imagine having that music at your 1980s birthday party. Thanks so much for watching. Drop back soon for some more 8-Bit Basic.